And guys, this is the 2019 Edexcel A-Level Maths Paper 1. Let's go! Number 1. F of x is 3x cubed, add 2ax squared, minus 4x, add 5a. Given that x add 3 is a factor of f of x, find the value of a. Okay, so by the fact theorem, if x add 3 is a factor, then f of minus 3 is 0. So that's going to give us 3 lots of minus 3 cubed, which is minus 81. Add 2a times minus 3 squared, so that's 18a. Minus 4 lots of minus 3, so add 12. Add 5a is 0. Okay, so we have 23a minus 69 is 0. So that gives us a is 3. Number 2, so we have the bar graph of y's cos x, where x is in radians. We have a copy of the diagram on the next page. We want to use the copy to show y cos x minus 2x minus 1/2 equals 0, has only one real root, giving a reason for your answer. Okay, so the way that we're going to do this is by using two graphs. So we're going to get minus 2x minus 1/2 on the other side. So we get cos x is 2x add 1/2. So 2x add 1/2 is a straight line with a gradient 2 and a y-intercept of 1/2. So if we sketch the line, then it looks something like this. Now there's only one point of intersection, so that shows that there is only one root. So only one intersection point. Therefore, only one real root. That the root of the equation is alpha, and that alpha is small. Use the small angle approximation for cos x to estimate the value of alpha to 3 decimal places. Okay, so we are given the small angle approximations. So cos alpha is approximately 1 minus alpha squared over 2. So our equation becomes 1 minus alpha squared over 2 is equal to 2 alpha add 1 half. Okay, multiply through by 2, we get 2 minus alpha squared is 4 alpha add 1. Okay, now from that we can get that alpha squared add 4 alpha minus 1 is equal to 0. Okay, now we need to use the quadratic formula. So, alpha is minus b, so minus 4 plus or minus, although we can see that alpha will be positive because it's to the right of 0, so I'm only going to use plus. The square root of b squared, so 16, minus 4 times 1 times minus 1, so that's root 20, and that is all over 2. Now, to 3 decimal places, that gives us alpha is 0.236. Number 3, y is 5x squared add 10x over x add 1 squared, where x is not 1, part A. Show that dy by dx is a over x add 1 to the power n, where a and n are constants to be found. Okay, so we're going to need to use the quotient rule. So, you are given it in the formula booklet. So we're going to use a u is 5x squared add 10x. So du by dx, or u dashed, is 10x add 10. And then v is x add 1 squared. Now, by the chain rule, differentiate the inside, we just get a 1. Differentiate the bracket, we get 2 times x add 1. Okay, now dy by dx is u dashed v, so 10x add 10, which we can write as 10 lots of x add 1 times x add 1 squared. And then it's minus v dashed u. So, minus 2 lots of x and 1 times 5x squared add 10x. Okay, and then that's all over v squared, so that's x and 1 to the power 4. Now, everything at this point has a common factor of x and 1, so we're going to divide through by x and 1. So, we get 10 lots of x and 1 squared minus 2 lots of 5x squared add 10x. All over x and 1 cubed. Okay, now let's expand the top. So x add 1 squared is x squared add 2x add 1. So 10 times it is 10x squared add 20x add 10. And then we have minus 10x squared minus 20x. All over x add 1 cubed. So, up on top, the x squared and x's cancel. So, finally, we have 10 over x add 1 cubed. Deduce the range of values of x for which dy by dx is less than 0. Okay, so the only part that can affect the sign is the x add 1 cubed. So, for this to be negative, x add 1 cubed must be negative. So, x add 1 must be less than 0. So, x must be less than 1. A. Find the first 3 terms in ascending powers of x of the binomial expansion of 1 over root 4 minus x, giving each coefficient in its simplest form. Okay, so 1 over root 4 minus x in power form is 4 minus x to the minus 1/2. Now, to be able to calculate these binomial expansions, with negative or fractional powers, we need the constant inside the bracket to be 1. So we're given the expansion for 1 add x to the power n. So we're going to bring out this factor of 4 to the minus 1/2. So inside we then have 1 minus x over 4 to the minus 1/2. Okay, so this is then approximately, because we're only getting 3 terms, plurate 1/2. Now, our first term is nice, it's 1. Now the second term is the power times the x term, so we have minus 1/2 times minus x over 4, so that's positive x over 8. Okay, and then the next one is n times n minus 1 x squared over 2. But remember, x squared for us is minus x over 4. So now we have minus 1/2 times minus 3/2 times minus x over 4 all squared over 2. Okay, so we have 1/2 times 1 add x over 8. Okay then, now even minus 1/2 times minus 3/2 is positive 3/4. X, or minus x over 4 all squared is x squared over 16. So 3/4 times x squared over 16 is 3x squared over 64. And then that is all over 2. So we get 3x squared over 128. So then, finally, we get 1/2 add x over 16 add 3x squared over 256. We're told the expansion can be used to work out an estimate for a root 2. We are given 3 possible values to sub into the expansion, so x is minus 14, 2, or minus 1/2. Part B, without evaluating the expansion, part 1, state, giving a reason which value of x should not be used. Okay, So this comes down to validity of binomial expansions. So we are told for 1 add x to the power n to be valid, the modulus of x must be less than 1. So for us, the modulus of minus x must be less than 4. Now the modulus cancels out in the negative, so the modulus of x is less than 4. So we can only sub in values less than 4 for the expansion to be valid. So part 1 would be x is minus 14 because the modulus of minus 14 is greater than 4. Okay, then B part 2 wants to know which value would lead to the most accurate approximation to root 2. So, the smaller the absolute value of x that we substitute in, the more accurate the approximation. So, here it would be x is minus 1/2 because it's closest to 0, so as the smallest absolute value. A 5, f of x is 2x squared, add 4x, add 9. Write f of x in the form a, lots of x add b squared add c, where a, b and c are integers to be found. So, completed square form. So, 2x squared add 4x add 9. Now, to be able to complete the square, we must have a single x squared term. So we're going to factor out a 2 throughout the whole thing. So this is 2 lots of x squared add 2x add 9/2. Okay, next we can now complete the square. Okay, so we can now complete the square. So we have 2 on the outside. Now on the inside, we're gonna have x add 1 squared now we need to subtract the 1, so we have 9/2 minus 1, so that's 7/2. Okay, and then we let the 2 back in, so this is and we can say f of x is 2 lots of x add 1 squared add 7. B. Sketched graph of y is f of x, showing the coordinates of any points of intersection with the coordinate axes and showing the coordinates of any turning points. Okay, so it's a quadratic, so there will be a turning point. When x is 0, y is 9. So the y-intercept is 9. So, what else do we know? Well, we also know that x add 1 squared is always positive or 0. So, adding 7 to it means it's always positive. So there are no x-intercepts. So, at the moment, we can say then, there's our curve, and we know we're going to hit the y-axis at 9, and we know we're not going to hit the x-axis. So, there's our x-axis. Now, to know where to put the y-axis, we need to know the turning point. So, we get turning points from completed square form. So, the turning point is at, now the x coordinate is the negative of the number in the bracket, so minus 1, and the y coordinate is the number on the outside, so 7. So, the turning point is minus 1, 7. Which means the y-axis is somewhere there. Now we know the y-intercept is at 9, or 0, 9. And that is our sketch of y equals f of x. Part C, Part 1. Describe fully the transformation which maps f of x onto g of x, where g of x is 2 lots x minus 2 squared and 4x minus 3. Okay. So, we need to expand, simplify and complete the square on g of x. So that we then know, how we get from f to g. So, g of x is 2 lots x squared minus 4x add 4. Add 4x minus 3. So that's 2x squared. Now we're going to get minus 8x add 4x. So that's minus 4x. And then we're going to get 8 minus 3, so that's 5. Okay, now let's complete the square. So that's 2 lots. X squared minus 2x, add 5 over 2. Which is then 2 lots of x minus 1 squared, and then subtract 1 on the outside, so that's 3 halves. Let the 2 back in, so that's 2 times x minus 1 squared, add 3. So, this guy has a turning point at positive 1, 3. So, f of x to g of x is a translation by, now our x coordinate has gone from minus 1 to positive 1, so we've gone right by 2. And then our y coordinate has gone from 7 to 3, so that's minus 4. And see part 2, find the range of the function h of x is 21 over 2x squared at 4x add 9, which was f of x. So, we know from completing the square that 2x squared add 4x add 9 has a minimum value of 7, so it's always greater than or equal to 7. So, because that's on the bottom of the fraction for h of x, as 2x squared add 4x add 9 increases, h of x decreases. So the maximum value of h of x happens when f of x has its minimum. So the max of h of x is 21 over 7. Which is 3. So, that tells us then that h of x is always going to be less than or equal to 3. But now, on the other end, we need to be careful. Can it be negative? And the answer is no, because 2x squared add 4x add 9 is always positive. So, because 2x squared add 4x add 9 is always greater than 0, h of x is always going to be greater than 0. So the range is that h of x is greater than 0, but less than or equal to 3. Say, solve for theta from minus 180 degrees to positive 180 degrees. 5 sine 2 theta is equal to 9 tan theta. Giving your answers when necessary to 1 decimal place. Alright, so sine of 2 theta is 2 sine theta cos theta. And tan theta is sine over cos. So this means then that we have tan sine theta cos theta now we could say that's equal to 9 sine theta over cos theta. I'm going to get everything on the same side, so minus 9 sine over cos is equal to 0. Now, multiplied through by cos, we get 9 sine cos squared. Sorry, 10 sine cos squared. So, 10 sine theta cos squared theta minus 9 sine theta is 0. Okay, now don't divide through by sine, factorise. So we have sine theta times 10 cos squared theta minus 9 is equal to 0. Alright, so this tells us then that sine theta is 0, or cos squared theta is 9 tenths. And that would then give us cos theta is positive or negative 3 over root 10. Alright, so the sine part is nice. So that tells us that theta is 0 and plus or minus 180. So that's 3 solutions. Now we need to deal with cos. So let's start with cos theta is positive 3 over root 10. Okay, now if we inverse cos that, we get theta is 18.4 degrees. Now, remember that cos is symmetrical through the y-axis. So there's also going to be a negative 18.4 degrees. So it's positive or negative 18.4. Okay, and then when cos theta is minus 3 over root 10, that's going to give us theta is 161.6 degrees. But again, using the symmetry, that's positive or negative. So 161.6. And there we go. That's all 7 solutions. At B, deduce the smallest positive solution to 5 sine 2x minus 50 is equal to 9 tan x minus 25. So, what's happened here is that x has become x minus 25. So the graph will have shifted 25 to the right. Now the reason we have 2x minus 50 in the sine term is because in there we had sine 2x. So what we're going to be doing is setting x minus 25 equal to one of our values from part A. Now, if we set it equal to minus 161.6, we're still going to get a negative for x. If we set it to minus 18.4, however, then we get x is 6.6 degrees. Number 7. In a simple model, the value v pounds of a car depends on its age t years. For car A, its value when new is £20,000 and after 1 year is £16,000. Part A. Use an exponential model to form an equation linking v with t. Alright, so we know its value is decreasing, so we can say v is a e to the minus kt. Now, we know when t is 0, the value is 20,000. So, v of 0 tells us that a is 20,000. So, v is 20,000 e to the minus kt. Okay, so now we need to find k. Now, we also know then, after 1 year, the value of car is 16,000. So, v of 1 is 16,000. So, from that, we get 16,000 is 20,000 e to the minus k. Okay, divide through by 20,000, we get 0.8 is e to the minus k. Take logs, so log 0.8 is minus k. So k is minus log 0.8. And that is gonna give us 0.223. So, now we can say that v is 20,000 e to the minus 0.223 t. Okay, then we're told the value of car A is monitored over a 10-year period. After 10 years, its value is £2,000. Part B. Evaluate the reliability of your model in light of this info. Okay, so whack in T is 10 and see how close we are to 2,000. So, if we put 10 into the model, we get £2,150. Now, that's not ridiculously far from £2,000. So, 2,150. It's quite close to 2,000. So, the model is reliable. And we're told car B has the same starting value as goal A, but the value decreases at a slower rate. We're asked how we could adapt our model so that it can be used for car B. So, the part of the model in charge of the rate of decrease is the minus 0.223. So because the value is still decreasing, that part needs to stay negative, but to make it decrease slower, we would decrease 0.223. Okay, number 8. So we have this curve which is y is x times x minus x times x add 2 times x minus 4. So straight away we can put on this point minus 2, 0 in the middle, and then 4 over here. Okay. Then we're told that the region R1 is bounded by the curve and the negative x-axis. Part A, show that R1 is 20 thirds. Okay, so to do that, we need to integrate the curve. So, we need to expand the brackets. So, y is x times x add 2 times x minus 4. So that's x squared minus 2x minus 8. So y is x cubed minus 2x squared minus 8x. Okay, next we know that R1 is the integral between minus 2 and 0 of x cubed minus 2x squared minus 8x. With respect to x. So that is x to the power 4 over 4 minus 2x cubed over 3 minus 8x squared over 2, so 4x squared. Okay, now when we put 0 in, we just get 0. So we got 0 minus what we get when we put in minus 2. So, 2 to the power 4 is 16, divided by 4 is 4. And then we have minus 2x cubed over 3. So, minus 2 cubed is 8. Oh, sorry, minus 8 times minus 2 is positive 16 thirds. And then we have minus 4 times 4, so minus 16. Okay, so we have then the negative of 4 minus 16 is minus 12. Add 16 thirds. So that's the negative of minus 36 thirds add 16 thirds, so that's minus 20 thirds. So that is indeed positive 20 thirds. Step. The region R2 is bounded by the curve the positive x-axis and the line x equals b, where b is between 0 and 4. Given that the areas of R1 and R2 are equal, verify that b satisfies b add 2 squared times 3b squared minus 20b add 20 is equal to 0. Okay, so there is R1 and R2. Now we know the area of R1 is 20 thirds. So that means the area of R2 is 20 thirds. Now, because R2 is below the x-axis, when we integrate between 0 and b, we will actually get minus 20 thirds. And again, that's because R2 is below the x-axis. So, what that tells us then is that R2 is the integral between 0 and b of y with respect to x. And we also know that's minus 20 thirds. Okay, so we've done the integral, so we know that R2 is this guy between 0 and b. And again, we know that's minus 20 thirds. So, we are going to get b to the power 4 over 4 minus 2b cubed over 3 minus 4b squared Now that is equal to minus 20 thirds. Let's get everything on the same side, so that's now plus 20 thirds equals 0. Okay, now let's get rid of the fractions. So to do that, we need to multiply through by 4 and 3. So we're going to multiply through by 12. So that's going to give us 3b to the 4 minus 8b cubed minus 48b squared and then plus 80 is equal to 0. Okay, so now we need to make sure that this is the same as b add 2 squared times 3b squared minus 20b add 20. So we could factorise. Originally I used algebraic division, but the video took ages, so I've decided not to use it. We can just expand these brackets and make sure that we get this. So that is how we're gonna do it. So I'm gonna use a table now across the top. I'm gonna put that, and then down the side, b add 2 squared is b squared add 4b add 4. So we are going to get 3b to the power 4. So that's a good start. Okay, and then we're going to get minus 20b cubed. And then we're going to get 20b squared. Okay, then 4b times 3b squared is 12b cubed. So there are all b cubed terms. So 12b cubed minus 20b cubed is minus 8b cubed. And then we're going to get minus 80b squared and then plus 80b then we're going to get 12b squared. So that's all of our b squareds. So 12 add 20 is 32, minus 80 is minus 48b squared. Okay, and then we're going to get 4 times minus 20b, so that's minus 80b. so the b terms cancel, and then finally 4 times 20 is 80. Now that is what we wanted, so we can chuck in a cheeky little QED. Quite enough done. Okay, then we're told the roots of 3b squared minus 20b and 20 equals 0 are 1.225 and 5.442. Therefore, b is 1.225 because we were told b was between 0 and 4. Part C. Explain with the aid of a diagram the significance of the value 5.442. Okay, so I've used this guy for my diagram. So 5.442 is to the root of 4. So what we were dealing with was the integral between minus 2 and b was equal to 0 because R1 and R2 had the same area, but 1 was above and 1 was below the x-axis. So if we did the integral between minus 2 and 1.225, then we would have got 0. Now, what part C is telling us also is that if we did the integral from minus 2 to 5.442, we would also get 0. So what this means is that the area above the x-axis and the area below the x-axis between minus 2 and 5.442 are the same. Okay, number 9, much nicer than number 8. So, given that A is bigger than B is bigger than 0, and A and B satisfy log A minus log B is log A minus B, part A, show that A is B squared over B minus 1. Okay, so, using the laws of logs, log A minus log B is a log of A over B. Now, in this case, we are being told that it's also a log of A minus B. So, that means here that A minus B is equal to A over B. Okay, now then, let's multiply through by B. So AB minus B squared is A. Okay, now we're trying to get A on its own. So, what we're going to do is add B squared and subtract a from both sides. So we get AB minus A is B squared. Now on the left, we can factorise. So we get A times B minus 1 is equal to B squared. And then divide through by B minus 1. Given part B, write down the full restriction on the value of B, giving a reason for the restriction. So, we know that A was greater than 0. So, that means that B over B minus 1 must also be greater than 0, which means B minus 1 must be greater than 0. Therefore, B must be greater than 1. Now, if we want another reason, then we could also say that B cannot equal 1 because then A would be undefined. Then A, prove that for all n in the natural numbers, so positive integers, n squared add 2 is not divisible by 4. Alright, so we can categorize natural numbers into two types, odd and even. So I'm gonna say let k be an integer. Okay, now we're gonna test n when it's odd and even. So, when n is odd, we can say let n be 2k add 1. And then n squared add 2 is 2k add 1 squared add 2. Now that is 4k squared add 4k add 1 add 2, which on a good day is 3. Now, we could say so that's odd, or we could say this is 4 lots of k squared add k add 3. So that is not divisible by 4. Okay, now let's draw n when it's even. So, when n is even, we're going to say let n equal to k. And then n squared add 2 is 2k squared add 2. So that's 4k squared add 2. Now that we can write as 2 lots of 2k squared add 1. So that's also not divisible by 4. So, we can then say, therefore, n squared add 2 is never divisible by 4. And at the end of a proof, you can always work in a cheeky little QED. Quite enough done. 2. Given that x is in the reals, the value of the modulus of 3x minus 28 is always greater than or equal to x minus 9. State, giving a reason, whether this is always, sometimes, or never true. So, I'm going to do this, thinking about their graphs. So, y is x minus 9 is a straight line like that, which hits the x-axis at 9. Okay, now let's think about just y is 3x minus 28. So, let's find where it hits the x-axis. So, y equals 0 would give us 3x is 28, so x is 28 over 3. Now, 28 over 3 is just bigger than 9. So, this guy is going to look something like that. Now, the modulus graph then bounces off the x-axis. So it's going to look like that. So we can see from the graph that the modulus graph is sometimes less than x minus 9. So we would say we can see from the graph that the statement is only sometimes true. For 11, a competitor is running a 20-kilometer race. She runs each first 4 kilometers at a steady speed of 6 minutes per kilometer. Then she begins to slow down. To estimate her finishing time, the time taken for each subsequent kilometer is modelled as 5% greater than the previous kilometer. Using the model, part A, show that her estimated time for the first 6 kilometers is 36 minutes 55 seconds. Alright, so the first 4 kilometers are just 4 times 6 minutes. So that's 24 minutes. Alright, now the fifth is going to be 5% greater than 6 minutes. So I'm now going to convert to seconds. So it's 360 times 1.05. Now that is going to give us 378 seconds. Now, a 6th kilometer is going to be 378 times 1.05. Now that is going to give us 300, and if we go to the nearest second, 397 seconds. So, if we then add those together, we get 775 seconds. Now that is, if we turn that back into minutes, that's 12 minutes 55 seconds. So the 5th and 6th together take 12 minutes 55 seconds. So 24 add 12 minutes and 55 seconds. Is indeed 36 minutes 55 seconds. Part B, show that our estimated time to run the rth kilometre for r from 5 to 20 is 6 times 1.05 to the r minus 4. So really, we've already done this, but so we know the 5th was 6 times 1.05 to the power 1. Or 5 minus 4. And then the sixth was 6 times 1.05 to the power 2, or 6 minus 4. Carry that on to the earth one, to love the earth one. Well, that's just gonna be 6 times 1.05 to whatever r is minus 4. So, what we've got is a geometric sequence here, where the common ratio is 1.05. But C wants us to estimate a total time in minutes and seconds to complete the race. So this is going to involve a geometric sum. So we're given the formula that we need. Now we need R and N. So they were horrible in part B by getting R involved. So for that part, I'm now going to use R is K. So our total time is the 24 minutes for the first 4 kilometers, and the sum from K is 5 to 20 of 6 times 1.05 to the K minus 4. Alright, so let's just focus on the geometric sum. So we know the first term was the 5th lap. So A is 6 times 1.05. Which is 6.3. Now R, the common ratio, is 1.05. Now, how many terms are we going to have in this sequence? We're actually going to have 16, because we want the 5th lap up to and including the 20th lap. So N is 16. So our sum is S16, which is, so A is 6.3, Now it's times 1 minus 1.05 to the power 16 over 1 minus 1.05. Now that gives us 149.04 minutes. Now we need to convert the 0.04 minutes into seconds. So multiply it by 60 and we get 2.4, which rounds down to 2 seconds. Now the mark scheme has 3 seconds, but I'm sticking with everything I know up to this point in my life. 2.4 rounds down to 2. So we have 149 minutes and 2 seconds. So the total time is that at 24 minutes. So the total is 173 minutes, 2 seconds. Well, f of x is 10e to the minus 0.25x sin x for x greater than or equal to 0. Part A. Show that the x coordinates of the turning points satisfy tan x is equal to 4. Alright, so we should start by saying at turning points dy by dx is 0. Okay, so we need to find dy by dx and set it equal to 0. So we're going to need to use the product rule. So first term we are going to differentiate e to the minus 0.25x and not sin x. So that's going to give us minus 2.5 because we get minus 0.25 times 10e to the minus 0.25x sin x. So we get minus 2.5 e to the minus 0.25x sine of x. So that's the first term, and then we differentiate sine x and not the exponential. So sine x goes to cos x, so we get 10 times the exponential times cos x. Now that we are setting equal to 0. Okay, Now, at this point, we now want to somehow turn this into tan x equals 4. So, there is a common factor of e to the minus 0.25x. Can we divide that away? Yes, because e to the minus 0.25x is never equal to 0. Now it would be a good idea in your working to state that just to be nice and thorough. So we can divide through by that then, so we get minus 2.5 sine x add 10 cos x is equal to 0. Okay, now, the next thing, can we divide through by cos x? And the answer to that is yes. So, now we can say cos x is not equal to 0. So we now get minus 2.5 tan x add 10 is 0. So add 2.5 tan x and then divide by 2.5. We do indeed get tan x is equal to 4. And then we have part of the graph of f of x. Part B answers to sketch h against t, where h of t is the modulus of 10e to the minus 0.25t sine of t for t greater than or equal to 0. So, it's going to be exactly the same, except every time it hits the x-axis, it's going to bounce back up. So, it's going to look something like that. So it can never be negative. Okay, then we're told that h is used to model the height in meters of a ball above the ground t seconds after it has been kicked. So think about it, you kick a ball, it goes up, comes down, bounces, goes up, goes down, bounces, etc. Using the model part C, find the maximum height of the ball between the first and second bounce. So, we want to find the height there. Now, what we're going to do is we're going to use f of x first to find the x or t coordinate. So, we know that it's a stationary point, so tan x is equal to 4. Now, we need to use radians because of the exponential term, so inverse tan, and we get to two decimal places that x is 1.33. Now that is the x-coordinate of the first stationary point. We want the second. So the period of time is pi, so we're going to add pi and two decimal places. That gives us 4.47. So we're now going to substitute t is 4.47 into h. So h of 4.47 gives us the modulus of minus 3.18. So our answer is 3.18 meters. Given part D, explain why this model should not be used to model the times between each bounce. Alright, so in this model, the exponential is responsible for the graph shrinking vertically because as x gets bigger, e to the minus 0.25x gets smaller. The sin x makes it periodic. So the sin x is why we're going up and down like a wave. Now, sine is periodic. The time between each bounce is not periodic. When the ball bounces up to a smaller height, it's going to take less time to hit the ground again. So the time between bounces is going to decrease. The time in the model is going to stay the same because again, sine is periodic. So we should say something along the lines of the model predicts the time between bounces remains the same, but in reality it will decrease. So curve C is y equals p minus 3x over 2x minus q times x add 3, where x is in the reals and not equal to minus 3 or 2. P and Q are constants. The curve passes through the point 3, 1/2 and has two vertical asymptotes at x is 2 and x is minus 3. A. Part 1. Explain why we can deduce that Q is equal to 4. Alright, so the vertical asymptotes come from trying to divide by 0. So, we know that when x is 2, and then 2x minus q must be 0. So 4 minus q is 0. So Q is 4. Now, the other asymptote is at x equals minus 3, because that's the value of x that makes x add 3, 0. To show that b is 15, so the way we're going to do that is by using the point 3 1/2. So x is 3, y is 1/2. It's going to give us 1/2 is p minus 9 over 2x minus 4, so 6 minus 4 is 2, times 3 add 3, so that's 6. So if we multiply through by 12, we get 6 is p minus 9. So p is indeed 15. Okay, then next up, so we have part of the graph with this shaded region R bounded by the curve, the x-axis, and the line x equals 2. Our job is to show the exact area of R is a log 2 and b log 3, where a and b are rational constants to be found. Alright, so we're going to need to integrate y between x equals 2 and the other limit. So, the first thing I'm going to do is find the x-intercept. So, we need 15 minus 3x over 2x minus 4 times x add 3 to equal 0. So, from that, we get 15 minus 3x is 0, which takes us to x is 5. So, what we've done that is multiplied the denominator on both sides, because we have 0 on the right. Okay, so now we know that R is the integral between 3 and 5 of y dx. Alright, now as it stands, we can't integrate y, so we need to now use partial fractions. So we are now saying then that 15 minus 3x over 2x minus 4 times x add 3 can be written in the form a over 2x minus 4, add b over x, add 3. Alright, now we just consider the tops of the fractions. So on the left, 15 minus 3x. Now on the right, if we combined the fractions, we would multiply a by x add 3 and b by 2x minus 4. So on top we get a x add 3 add b times 2x minus 4. Alright, now let's choose a clever value to make b disappear. So that would be x is 2. So on the left, we're going to get 15 minus 6, which is 9. And on the right, we're going to get 5a. Now, because of what's coming, it's going to make it easier to write a as a decimal. So we divide by 5, we get a is 1.8. Okay, then to get b, we need to make a disappear, so we're going to use x as minus 3. So that gives us 15 minus 9, so 24. Is 2, no it's not, sorry, 2 times minus 3 is minus 6, minus 4 is minus 10. So 24 is minus 10b. So b is minus 2.4. Alright, didn't write that very well. Okay, so now we know that R is the integral between 3 and 5. Of 1.8 over 2x minus 4 minus 2.4 over x add 3. dx. Alright, so if we just integrated 1 over 2x minus 4, then we're definitely going to get something to do with a log 2x minus 4. Now, if we differentiated that, we would get 2 over 2x minus 4. So, we don't want that, we want 1 over, so we need an over 2. So it's 1.8 log 2x minus 4 all over 2. And then the other one is minus 2.4 log x add 3. Between 3 and 5. Alright, so let's whack 5 in. So, we're going to get 0.9 log 6 minus 2.4 log 8 minus what we get when we put in 3. So we're going to get 0.9 log 2 and then minus 2.4 log 6. Alright, so now we need to turn this into something just in terms of log 2 and a log 3. Good times. So, we have 0.9 log 6 and then minus 2.4 log 6. So add 2.4 log 6. And then we have minus 2.4 log 8 and then minus 0.9 log 2. Alright, so we can say then that we have 0.9 lots of log 6 minus log 2 and then add 2.4 log 6 minus 2.4 log 8. Which actually we can factorize. So let's say we got plus 2.4 lots of log 6 minus log 8. Alright, it's gonna start to get nicer. So, log 6 minus log 2 is a log 3, because we do 6 divided by 2. So we have 0.9 log 3. And then we have 2.4 log of 6 over 8, which is 3/4. Alright, now the log 3/4 is a log 3 minus a log 4. So we have 0.9 log 3 add 2.4 log 3 minus 2.4 log 4. So, we have 3.3 log 3 minus, okay, so log 4 is a log of 2 squared, so the power can come out the front, so we have minus 4.8 log 2. And that's it. 14. The curve C in the standard Cartesian plane is defined by x is 4 sine 2y, 4y between negative and positive, pi by 4. The curve passes through the origin. Part A. Find the value of dy by dx at the origin. Alright. So, as it stands, we can find dx by dy. So, sine of 2y will differentiate to 2 cos 2y. So we have 4 times 2 cos 2y. So 8 cos 2y. So dy by dx is just the reciprocal of that. So 1 over 8 cos 2y. Now, at the origin, y is 0. So, y is 0 gives dy by dx is 1 over 8. Because cos of 0 is 1. Part 1. Use small angle approximations for sine of 2y to find an equation linking x and y 4 points close to the origin. Alright, so we are given these, so when theta is small, sine of theta is approximately theta. So sine of 2y is approximately 2y. So, x is approximately 4 times 2y, so 8y. So, from that we could say y is x over 8. Part 2 explain the relationship between the values found in Part A and B Part 1. So all that I want us to say here is that the gradient of the line we just found is 1/8, which is the same as the gradient of the curve at the origin, which was also 1/8. In the final part, we want to show that for all points on C, dy by dx is 1 over a root b minus x squared, where a and b are constants to be found. Alright, so we know that dy by dx is 1 over 8 cos 2y. Okay, now we know that x was 4 sine 2y, so we need to transform cos 2y into something to do with sine 2y. So we can say that cos 2y is the square root of cos squared 2y. Now we know that cos squared add sine squared is 1, so cos squared 2y is 1 minus sine squared 2y. So we have 1 over 8 times the square root of 1 minus sine squared 2y. Alright, now then, we know that x was 4 sine 2y. So, sine 2y is x over 4, so sine squared 2y is x squared over 16. That means dy by dx can now be written as 1 over 8 root 1 minus x squared over 16. So, what we now want to do is bring out that factor of 16. So, this is now 1 over 8 times the square root of 1 over 16 times the square root of. So inside of this one, we've now multiplied by 16. So we have 16 minus x squared. So finally, that is 1 over 2 square root of 16 minus x squared. Guys, that's paper 1 done. I think it got pretty tough there at the end, so I really hope this has helped. If so, please subscribe, give us a thumbs up. Hope to see you in papers 2 and 3. Best of luck in your exams. For now, take it easy, take care.